So in the past, I've looked at the ability to add a custom CSS class to a sticky element using a Angular component. But I believe I was listening to the CSS Tricks podcast a couple of weeks ago, and I hope I'm not getting this reference wrong, but I believe Dave Rupert was talking about simplifying this type of sticky or stuck CSS application by using a top value of -1 pixels. So I wanted to explore this simplified approach in Angular 11 here. So I have my header, and my header is here. We have a bunch of sections, and the header is going to use position sticky. And if we jump over into the CSS, we can see here that header is position sticky. And this is what Dave Rupert was talking about, using a top of -1 pixels. And what that means is when the element moves from a static position on the page to a sticky position on the page, it's going to hover at -1 pixels based on the overflow container, which in our case is the browser viewport. And the -1 here, the reason that this is a simplifying approach is because it means that the top edge of this host element is going to overlap with the viewport, and the bottom edge is going to be within the viewport. And we're going to be able to add that sticky class when that type of intersection occurs. You can see here I'm setting a background color and a color and some box shadows. And if we jump over into the browser, what you'll see is that as I scroll down, my headers become sticky and the CSS changes. And if we observe, or if we look at the element, you can see that here I have that header sticky class. And not only do I have it when it's being stuck, but as I scroll down, you'll notice that it gets removed and then added and removed. Now, this doesn't always work. We'll talk about that in a second. Let's take a look at how we're actually applying this CSS class. This sticky class attribute here is actually doing double duty. It is both providing the CSS class that we want to apply to the host element, and it's also acting as a selector for an Angular directive. And here is the Angular directive. You can see it is targeting based on the attribute sticky class, but it's also using an input of sticky class. And what we're going to do here is in the init, we're going to first run outside the Angular zone because we don't need to trigger change detection when this all takes place. And we're going to set up an IntersectionObserver. We're going to provide the callback that looks at whether or not we should add the CSS class. And we're going to provide some thresholds. Sorry, this is supposed to be like that, as to when those callbacks are fired. I'm using both a 0 and a 1. The 0 helps us detect when any portion of the host element enters the viewport, and the 1 helps us determine when the entire element has entered or exited the viewport. And then I'm going to go ahead and observe the host element here. And if we jump down into our callback, what you'll see is we're looking to see how the top and the bottom edges of the host element interact with the viewport. And in this case, because we have a top of -1 pixel in our CSS class, that means that when the top edge of that bounding rectangle is less than 0 or above the top edge of the viewport, while the bottom edge of that bounding client rectangle is greater than 0 or below the top edge of the viewport, in that case, we're going to add our sticky class. And if that overlapping isn't taking place, we're going to go ahead and remove our sticky class, right? Because if we look again in the browser here, if we go down to this and we look at it, so here, let's grab our header and let's do $0.getBoundingClient rectangle. What you can see here is that the Y is -1 pixel, again, because that's what we have in our CSS class for the position sticky. So that -1 pixel, we can see that the top here is -1 pixel and the bottom is 57, right? So if we jump back into our directive, we can see that the top of -1 is less than 0 and the bottom of 57 is greater than 0. And in that case, it has the sticky property, and we're therefore going to add the sticky class. And if we scroll up a little bit until it goes away, and now we do the same thing, what we can see here is that in this case, the top is now 20. So it is no longer less than 0, and it is no longer, therefore, going to receive the sticky class. So this is it's pretty simple. I mean, right, if I scroll here, this is the entire directive. It's much more simple than the directive I had explored last year in Angular 7, I believe it was. Now, I will say that this doesn't always work. And let's see if I can get it to not work. So if I hold down the Command key and press down, I'm going to jump back and forth a couple of times to see if I can get it to not fire on the bottom one. Let's see. Come on, demo gods. There it goes. So you can see here that clearly the element is sticky, but we failed to add our sticky CSS class. And the reason that that happens is because we're using the intersection observer, and the intersection observer callback is only firing when the intersection state changes. Now, because we're scrolling down fast, what we probably did was the intersection observer fired on header 5 here as it was entering the bottom of the viewport, and then the next time it went to observe that element, it was overlapping with the top of the viewport. So in both successive checks from the intersection observer, it went from an intersecting state at the bottom to an intersecting state at the top, and therefore the callback wasn't fired on that second call because the intersection state didn't actually change. It was overlapping at the bottom, and then it was overlapping at the top. So we checked on the overlapping of the bottom. It didn't meet the overlapping criteria here, and then the callback never fired at the top because, again, it had moved from an overlapping state to an overlapping state, and therefore a callback never got fired, and therefore our CSS class was never applied. So there is an edge case there when someone is scrolling very quickly and you skip over kind of a non-overlapping to an overlapping state. To get around this, we could probably do something like add a set timeout and call our get bounding client rectangle on our own explicitly. In that case, our directive starts to get more complicated. We might want to just revert back to using a more explicit custom component like I had explored in a previous post. It depends on the use case here and how likely this is to happen. But in any case, it was definitely an interesting approach to use. The position sticky with the top of -1 pixels definitely created a much more simplified Angular directive, and anyway, just worth exploring, I thought.